Hello, and welcome to our slide deck presentation for the Hackathon Challenge. We are Team Lackluster Dev Metal, consisting of Alexandria M, Liam D, Kung Sonny Cow, and myself, Jim Lister. Project Overview. The project. A translation app that has basic language translation functionality and includes additional features such as file-to-text and image-to-text translation. And the project duration was approximately 1 week from May 20 to May 27. The purpose. The original idea was to create a front end for a translation API. However, we were able to complete the MVP quickly and add several more features such as reading text and image files. The main goal was to create and deploy a web application with reasonably well-functioning components and to develop them as a team. In doing so, to gain experience in a collaborative environment, exploring the nuances of project management and version control throughout GitHub. Our roles. And really, we collaborated on all aspects of the project, which included project management, front-end development, UI/UX design, back-end integration and deployment. Our responsibilities included on the front end, creating the UI components, styling in CSS and Bootstrap, integration with the back end, which included integrating APIs and external libraries, handling translation logic, managing state, handling form submissions, error handling and persistence or local storage. We used Trello to keep track of features that needed to be implemented and our progress on each feature. In this way, we could easily see what tasks were available and pick them up whenever we had time to work on the project, which allowed us to work autonomously. In the next section, we'll be looking at the list of features, which include navigation, translator, file-to-text translator, image-to-text translator, and preloader. Just to quickly note, the simple navigation component basically allows the user to swap between basic translator functionality and image-to-text functionality. The image-to-text component shares basic functionality with the rest of the app in that it translates the input text into the output text. However, it has the ability of OCR, optical character recognition, meaning you can upload a picture of something like a sign and the application will convert the words in that picture, copying them into the input field. The file-to-text feature has an input type of file and therefore gives the user an option to upload a text document and have the contents transferred to the input field, thus allowing you to translate the file utilizing the shared functionality of the translation components. The Translator MVP is the foundation and core of the product overall. Utilizing LibreTranslate API, the translator uses state to record the input and output languages as well as the input and output texts. Axios is used to make the call to the translation API. Axios is an external library used to fetch APIs and provides a simplified and convenient way to send HTTP requests and handle responses. The basic functionality overall is that you select your input and output language, input the text you would like translated, click the translate button, and the translator text will show up in the output field. Finally, although not integral to the functionality of the app, the preloader gives the user a visual cue to indicate that the app is functioning, i.e. translating the input. This was achieved using external library React loading to create the loading animation and call it when isLoading state is true using a ternary operator. In the next section, we'll be looking at the external libraries and dependencies utilized in the development of this application. These include Axios, Bootstrap, Tesseract, and React Loading. We integrated Axios into our project to handle API calls smoothly. Axios is able to use promises to catch errors in API requests or responses. Axios is a versatile promise-based HTTP client designed for both Node.js and browser environments. It offers a unified codebase, enabling it to run seamlessly in both environments, and it utilizes the native Node.js HTTP module on the server side and XML HTTP requests on the client side. We chose Bootstrap as a CSS framework because of its popularity in the industry. We felt that it would be a good thing to gain experience with and it would help to give our app a professional appearance and implement responsive design. Bootstrap is very flexible and customizable, and using it streamlined the process of adding styling to our application. On the advice of Coder Academy staff, we turned to Tesseract for the image-to-text component. Tesseract is the JavaScript version of an open-source OCR engine developed by Google. By installing the library, we were able to create a compact and efficient function to handle an upload image and extract the text from it for translation. Tesseract can handle various image formats using machine learning algorithms to analyze the visual patterns of characters and accurately recognize text within an image. Tesseract provides a simple API that enables us to integrate OCR functionality into the application easily. With its robust performance and flexibility, Tesseract was an excellent choice for the text extraction task within our application. We noticed that at times the LibreTranslate API was slow to respond and it was not clear to the user whether the app was functioning or not. To address this issue, we integrated the React Loading library, which provides a range of animated visual components that indicate when the app is fetching data. This helps the user to understand that the app is currently loading and adds a professional touch to the interface. So just to briefly go into styling, we used a combination of CSS and Bootstrap to achieve our styling. Just to surmise what this involves quickly, we can break it into 3 separate categories with visual components, responsive design, and user interface. As for error handling, we can also categorize that into 3 basic components. The API error handling, which includes the error handling code in LibreTranslate API, using Axios to catch and reject promises when API requests fail, handling errors when the API response doesn't meet the specified criteria. Text input error handling, which is displaying a message when the entered text doesn't match the selected language, rendering an error message when incorrect input is used, and time-based error handling, which is clearing the error message based on a specific time duration, automatically removing or hiding error messages after a certain period. Due to its simplified and continuous deployment, we decided to go with Netlify. Netlify is a cloud-based hosting and deployment platform designed for static websites and modern web applications. Deploying to Netlify went smoothly apart from a few minor issues we were able to circumnavigate. The first was creating a fork of the main branch of the repository due to the access rights of the GitHub to Netlify connection. Once this was done and the application was deployed from the fork, the continuous deployment was enabled. We did have to do a couple of other manual overrides like altering the build command to CI equals npm run build and to include a redirects file in the public folder to allow for the site's navigation once deployed. Overall, Netlify simplified the deployment process, gave us great performance and provided a range of features that made it an excellent choice for the deployment of our application. So in the next section going forward, we'll be looking at the takeaways, challenges, limitations, what did we learn, and what would we do differently, as well as the next steps. Challenges. The initial API we attempted to use for OCR did not work correctly, so we had to swap it for Tesseract. We also had to switch translation APIs due to difficulty obtaining a key for our first choice. We encountered an undocumented error when trying to deploy the site to Netlify, which required us to manually change the build settings. Thankfully, Stack Overflow was helpful with this. Other challenges included familiarization with codebase and understanding locations of different components and functions. Limitations. As several members of the team have jobs and children, time management was challenging. However, we were able to organize and divide tasks so that everyone could contribute. Another rather severe limitation is the lesser quality of the open source LibreTranslation API, which sometimes omits words or translates incorrectly. JavaScript's inbuilt file reader reads text as UTF-8 by default. If the upload text file is not in that format, it may not work. And Tesseract does not auto-detect languages, which means that the user has to select a language manually when uploading an image. What we would do differently. If we were to create a commercial version of this app, it would be worth using a paid API such as Google Translate to provide high-quality translations. As the team had no prior experience with CSS frameworks, we had to learn on the job. In future projects, the implementation of a CSS framework should go more smoothly. What we learned. One of the most advantageous learning experiences of the whole project was learning how to collaborate in a GitHub repository. We learned how to manage branches as well as pull requests and general merging in Git. We became more familiar with implementing third-party APIs and libraries, and Bootstrap was another big one to get our heads around as a big part of the learning experience. Next steps. Camera image to text function. A stretch goal that we weren't able to complete within the hackathon was adding camera functionality. The function will use the capacitor camera API to access the camera on the user's device so that they can take and upload a picture of text that is right in front of them without leaving the app. Error handling and debugging. Bug identification and error handling will be an ongoing process. The app requires thorough bug detection and debugging to ensure the application functions as expected. User testing and review. Being at a stage where it's an MVC, the application is for sure ready for user testing. This stage would allow for user research and ultimately improved UX design and overall functionality of the application. And that just about wraps it up. Thanks very much for taking the time to review our presentation.